Hi dear students, the topic of today's session is how can we convert an audio signal to binary? In our previous classes what we have discussed that how to convert any number into binary, then how to convert any textual data or text to binary, and today's topic is that how we are going to convert audio to binary. So as it's understood thing that audios are usually in the form of sound waves. As you can see in the title page, that we have wave and we are recording it at different intervals. And then we are storing these two values, time interval and different samples. But in order to better understand the concept of audio to binary conversion, we need to understand few terms related to sound. The first term is sound sampling. As the term is very much clear from its name, that we are collecting the samples of sound, but yes, at set time intervals. You can see here in the graph that we have two values at different axes. One is time samples and the other one is sound values. And we are recording the sound samples after 1 second till 12 seconds. So time intervals are 12 and the sound values ranges from 0 to 50. So in the table below, you can see here that at different time samples, we are recording sound values. This is the way that we can store or record our sound samples. Next thing is sample rate. So sound sample and sample rate are two different things. In case of sound sampling, we are usually setting time intervals for recording a sample. But in case of sampling rate, we are counting the number of samples that can be taken in 1 second. Usually, the word rate is being used for per second, where in any definition, if you can see this word rate, so it means per second. So number of samples being collected per second is known as sample rate, and we usually measure it in hertz. Hertz mean 1 hertz is equal to 1 sample per second. Okay, Ji, now let's proceed to next definition, that is sampling resolution or sample resolution. So what is sampling resolution? As the name indicates that we are done with our conversion of audio or sound data into digital data. Now the step is that we are going to store these values into a register. So what is this process? That we are going to convert it into binary, and the number of bits that are used to represent each sample is known as our sampling resolution. Let's proceed further, and this question would be quite helpful for us to understand the concepts of sound, sampling, resolution, etc. etc. So the question is saying to us then an audio CD has a sample rate of everything is mentioned in the question, that what is sample rate? 44,100. So normal frequency is 44.1 hertz, and we have converted the same frequency into sampling rate. Okay, Ji. So this question is saying to us that an audio CD has a sample rate of 44100 and a sample resolution of 16 bits. Yes, what does it mean? That we are storing this sample into 16 bits. The music being sampled uses two channels to allow for stereo recording. So you will be getting the idea when we are recording the sample from two channels. So definitely we are multiplying the values with 2. For one channel, yes, it's very simple. We are directly calculating the value, and for two channels we are multiplying it with 2. Now we need to calculate the file size for a 60-minute recording. So very simple. If I am going to convert this 60 minute into second, for the reason of, as we have discussed earlier, in order to calculate sample rate, we are going to measure it per second. So first step is that we are going to convert this into seconds. Alright, so we need to calculate the file size. what are the steps that we need to require, or what are the values do we need to require for calculating the file size, sampling rate, sampling resolution, and length of samples in seconds, right? So what are we doing now? Sampling rate is 44100, and what is sampling resolution? It's 16 bits. Okay, and in 60 seconds we have 60 minutes we have 3600 seconds. So we are going to multiply all these values. Now what are we doing? We are multiplying by 2 since there are 2 channels being used, right? So you can see here that the same value we are going to multiply by 2. Then we are going to divide by 8 to find number of bytes. Yes, how many bytes are required to store the file? File size are being used to store the bytes are being used to store the file size, right? So in order rather than calculating or multiplying the values, we can leave the values as it is. Okay, what is the next step? We are going to divide it with 2. If I am going to convert these bits into bytes, in question it's given bits and we need to convert it into byte for calculating the file size. And yes, if I am going to convert it into megabytes, so how I am going to go about it. If you want to learn about different file size and different conversion storage units, so kindly refer my video of storage units where I have taught about different conversions of storage units, how we are going to convert kibibytes into megabytes, etc., etc. All right. So rather than going for complicated multiplication, I always recommend to leave such questions like this. And now let's proceed further. So here it is. Yes, this is going to be cut with this thing. And then we are going to cut 1024 into 1024, 60 into 60. So it's 10 6 are 60 and 6 1s are 6. 6 6 are, let me check what is the conversion of 124. So when we will multiply the rest of the calculation by using the calculator, so the answer will become 605 megabytes. Okay, so we have 42, 6 6 are 36, and then we have 44. So this number is not multiplicable by 6, so we will try with some other integer, and this will definitely help us to solve this question, that the answer would be 605 megabytes. So hopefully you got the idea of what is sampling resolution and how are we going to calculate the file size by using these samples, sampling resolution and sample rate. So dear student, don't forget to watch my video, subscribe my channel, and keep sharing my channel links as well. See you in next class with the topic of conversion of images into binary. Till then, Allah Hafiz.